Alright, welcome guys. In this tutorial, just to give you a quick update for those who been with me for a long time, I had a break from making tutorials. I had to focus on my work, on my professional career, and for past 1 year, a little bit over 1 year, I started using Unreal. We started using Unreal Engine in our studio. So here's tutorial about Unreal Engine basically. So I'll be making a random selector, and if you know, it's a composite node used in behavior tree. We have the sequencer, no sequence, just the sequence, which will go from left to right in a sequence. So as long as the child succeeds, it will continue to the next one. So just to show you that quickly, I'll run the game. This is the game which basically has the static AI which runs the behavior tree. So if I move to behavior tree, if I start the game and move to the behavior tree, you can see it starts moving from left to right, and it just waits in the sequence. So first it will wait 1 second, then it will wait 2 seconds, 3 seconds, and at the end it should be 4. So I will change it right now. And now we have another composite node, which is Selector. We also have simple parallel, but it doesn't matter in this tutorial. Selector basically goes from left to right, and it will execute as long as some child fails. So if the first one fails, he will continue to the next one and try to find the one that will succeed. So because of the wait task node, which always return succeeds, we can't execute further. So if I continue, if I play the game, you can see it waits 1 second, and then it will be stuck here because basically it returns succeeds, so there's no point to go to the other one. And that's how Selector works. So I make a decorator to wrap around this, which is force fail because there's a decorator called force succeeds, and if you can read the description, someone wrote that forcing fail to result was not implemented because it doesn't make sense. And yes, it doesn't make sense, but in this case it makes sense because I want to show you the tutorial. So I make a decorator which is force fail. It doesn't matter, the implementation of it doesn't matter because you won't be needing that, but just for the sake of tutorial I made it. So as you can see, if I force fail the first one and the second one, you will see the behavior tree will go from left to right, and it will stop at the wait 3 seconds. But first it will execute waiting for 1 second, it will go to the next one, and then it will go to 3 seconds. And after the third child, it will go up to the parent. So if I start, you can see it waits and it fails, and it moves to the 3 seconds, and then it succeeds. That's why it returns to the parent again. So that's two composite node that we use the most in Unreal Engine. So right now I made the third one, random selector. You might be needing that. I use it sometimes when I want to like select random task. So I have two tasks for AI. So for example, shoot or melee or shoot differently. So I used random selector just to add a little variation to my NPCs. So to demonstrate that, I need to add force fail to each of the tasks, because we want to like traverse the child nodes randomly. So if I press play right now, you'll see that it selects the random child. It selected 4 seconds first, then it will jump to the random one, it jumped to the wait 1 second, then to the third one, and then to the second one. And as you can see, it jumps randomly. After that, it comes back to the root and executes the tree again. So as you can see, it's totally random because we also use a random node in C++, but yeah, that's it. Alright, so let's start the tutorial. So I assume, at least, because it's more intermediate and advanced tutorial, I assume that you already have a project that you are working on, or it's already set up to use C++, so I won't be going over that. But if you already have your own AI, I need to create my basic AI here for those who don't have. So if you already have AI, just skip to the part marked in the video. But right now we will create basic AI that will just run the behavior tree. So let's go to content. Let's go to blueprints. I'll create new folder. I'll call it tutorial. And here we will create basic character. So we can select blueprint class. We'll select character, and it will be BP tutorial AI. So this will be our character. Let's open it. Okay, here it should be open. It's empty. Select the mesh. We'll select skeletal mesh, SKM many simple. Let's move it down. It doesn't matter because he will just stand there. Okay, now we throw him. Let's throw him on the scene. And if I press play, he's on the scene, but he doesn't have a behavior tree yet connected. We need to run it. I could do it in C++, but it would be easier and faster to set up in blueprints. So let's go to blueprint class again, expand all classes, search for AI controller, and pick this one, the parent one. Select it. Let's call it AIC, which stands for AI controller, and let's call it tutorial AI. Okay. We will need behavior tree, obviously, so artificial intelligence, right click, behavior tree, let's call it BT underscore tutorial AI. Alright, so we have those three things, and let's open behavior tree, and let's for now just run a wait task. So we will see it, see that it works. So we will wait 5 seconds. That's the basic behavior tree. Now let's go to our character that we set up before. Go to class defaults here, search for AI D, and you have this AI controller class. And now select the AIC that we created, AIC tutorial AI. So it will run the controller. The AI controller class will possess the spawn. Let's open the AIC, go to event graph, and on begin play, just run behavior tree. Run behavior tree and select the behavior tree that we created. So right now, if I play the game, this should run. So let's see. Let's play, and I will open the behavior tree, and as you can see, it runs. So that's the setup we needed. And now let's go to our main tutorial. Let's go to the C++ classes. Click new C++ class. It doesn't matter where you put it. Go to all classes. Search for it's called BT Composite, I think. Yeah, BT Composite node. And as you can see, there's already FreeMate, Selector, Sequence, and Simple Parallel. They all inherit from BT Composite node. So select this one, click Next, Public, and we call it BT Composite underscore random selector. So create class. It will be created, and after that we will go to our IDE and edit that. Now I have it. I'm using Rider as my IDE, so you can use Visual Studio, it doesn't matter. but Rider is like very helpful in writing C++. So let's open that. Alright, so I have this class opened. As you can see, I have the header files on the left and C++ files on the right. So as you can see, it's basically empty right now. And the first thing I can recommend is to look at the source code, because Unreal is open source code, so you can look at how other composite nodes are made. So if I search for files in Rider, I have Control P to search for all files. In Visual Studio, I don't remember, it's maybe Control Shift F or something, or Control T. But if you write pt composite, then you have the selector and the sequence one, and you can see how they are written. So let's start from the sequencer, because I think it's easier. Let's see the header file first. So you have a function called getNextChildHandler, which will basically return the index of the child that needs to be executed next. Those two doesn't matter. So let's go to C++ file. So we have a constructor which basically gives it a name, sequence. Then we have this getNextChildHandler function. And a small notice: I'm not a C++ expert or anything. I just try to make games. I learn from my own experience, and don't trust me on everything, okay? I'm also like learning and failing and repeating myself, but if you force yourself to do stuff and to solve problems, then you will learn. Okay, so we start from making a local variable which will store the index of the child that we want to execute next. We assign it a special child enum, which is basically an integer, but Unreal Engine will know that this integer means that we want to return to parent. So we want to return to the root of the behavior tree. So if you hover over it, you can see that the value is -2. I don't know if you can see it, but the value is -2. So yeah, Unreal will know that if the ID is -2, then return to parent. Then we have a condition. We check if previous child was not initialized, so which means basically that it's the first time that we enter the subtree. Then we want to assign the index of 0. So you want to execute the first one, as the comment said. And the next time we enter the tree, this won't be true anymore. So we will go to this statement. So if the previous child succeeded and there's more child in this subtree, just increment it. So that's how basically sequence work. Okay, so let's now go to the selector. So we have getNextChildHandler, which is a function, the same function as we implemented before in the sequence. So as you can see, it's the same. First, we just initialize it to default value, which is return to parent. So if it doesn't know what child to select next, it will just go up to the behavior tree and start over again. So if it's not initialized, the same thing, start from 0, start from left, start from the first child. And this is the difference. So if the previous child was failed, move on to the next one and see if this succeeds, and then return it. So that's very simple. That's the same basically. And with that knowledge, we can start our own composite node. Move this to the right. We have random selector. As you can see, we need to override this function, getNextChildHandler. So let's see. We just write getNextChildHandler, and here's the signature of it. It's quite long, but Rider helps me autocomplete it. I will leave it here so you can pause and copy that. So basically it takes the last result that we talked about earlier and the index of the previous child, and this I'll explain in a second. You can also create a constructor, so you'll call it ubt composite random selector. It needs to be the same, and it needs to take in f object initializer. By reference, it should be const, and we will call it object initializer. And Rider is telling me that non-explicit converting constructor, that we basically needs to make it explicit. Okay, so now we have this constructor, and let's generate the definition of those two functions in C++. So I will just select it, and I have generate definitions by declarations, and I can generate those, and you can see they will be generated on the right. So I have already generated bodies there. So we will start from constructor. There's a property in composite node. It's called node name, and we will just call it random selector. This is how your node will show up in behavior tree in Unreal in editor. So we will name it random selector. Now in get next child handler, we can open up a sequence on the left, so we can just look at it and just copy it because it's almost the same. So first we'll start from parent index. We want to return to parent. We will write next child idx. I don't know why x is there, but first we want to return special child, return to parent. So this is the default value. We want to return it if we don't know what to execute next. So we will return next child at the end, next child ID, done. Okay, so we have the same thing. If previous child equals special child not initialized, which is also just a special int value, which is -1, as you can see from the comment if I hover over it. If our subtree wasn't initialized, any child wasn't activated, then we want to select random child. So we will go next child ID equals fmath, which is the library for mathematics operations, I don't know. Fmath, we will call rand range, which will get the value from random range. We want to get the value from 0, which is our first child, and the number of child that is available in this subtree. So there's a function called getChildren num, which returns the number of the children, but we need to subtract 1 because the index counts from 0. So that's the first part of the if else statement. Else, wait, why is it green? Okay, because there's return get next child handler super, so we just delete that because it was gray because we returned before, so it doesn't matter, just delete the call to super. So else, now we want to check else if last result equals ebt node result. So we just copy from the left. You can see I always have a reference. I don't write from my mind if this is fresh knowledge, so always have a reference next to you. So we want to move on to our next child if the first one fails. So that's why we compare it to failed. And for now, we don't have second condition yet, because we want to check, we want to make basically an array of our childs and move through each of them at random. We don't want them to repeat. So we need to have an array that will memorize which child we already processed. But for now, to start simply, we'll just move on to the next random child. So we can just copy this and paste it here. So first it will select the random child if it was not initialized, and after that, if the last result was failed, we'll select another random child. So for the purpose of testing, we can change this to succeed because we don't have a failed decorator yet. So, and the wait node returns succeeds. So we need to change it to succeeds in order to check if it works. So with that in mind, we can build the editor again and wait when it compiles and see if it works. Alright, so the project is built. We have the editor opened. Let's see if our node exists. So BT, well, oh, sorry. I have two windows, so I work on two windows. The Control P to find the asset. Let's open our behavior tree. And now, if we made everything good, we should right click, and as you can see, under Composites tab, there should be Random Selector. Click Random Selector, will appear here, and right now, we can delete the selector. If we connect those, let's duplicate weight two times maybe, or four times. So it will be at this the same as the introduction. So right now it should basically randomly select any node when it succeeds. So let's start the game. Let's open our behavior tree, and you can see after 5 seconds it moves to random one. After 5 seconds it will select another random one, and after 5 seconds again it will select another random one. And for our luck it chose every different one, but from our implementation it should randomly select any of the 4, so it can also select itself again, so it can also select the second child again, but we'll fix that. But for the first part of the tutorial, because the video is already long, I checked, I'll split it into 2 parts. So the first part, you have truly random selector, and it will select truly randomly any given child, and it can also repeat itself. If it's the behavior you want, then there you go. Remember one thing, that in the code here, if you want it to be a selector, just change it to failed, because right now we change it to succeeded because the wait only returns succeed. But in the next part of the tutorial we will create a force fail decorator which will fail the task, and we can change this to failed and it will work as it should. So thank you guys for the first part, and I will see you in the next one. Goodbye.